Um, so I'll look at 104 on 7.4. Eight x to the fifth minus 98 x to the third. So if you look at, I think your algorithm is going to probably be more and more important as you're going further along. And in 7.5, it's going to be the culmination of what we've learned so far. This thing is the polynomial descending order, leading term positive, and is there a common factor? The numerical coefficients are 8 and 98. It's even, so at least what comes up? At least a 2 comes up, right? The question is there more than 2? If you don't know, you can just take 2 out and then check and see again, right? Now, in terms of variable, is there anything in the variable that comes out? A cube. So, just for the sake of doing it right now, we could say at least a 2x cubed comes out, and that leaves us 4 what? X squared. The cube has come out. We're taking a 2 out, so we have what? 49. Now you can check and see, is there any other numerical coefficient values that come out? Well, 4 and 49 have nothing in common. So now then, this is a completely factored form. Can you factor that any further? Well, it's a binomial, right? There's 4 choices in the binomial. Difference of squares, sum of squares, difference of cubes, sum of cubes. Does that fit any one of those 4? So the question is the first term a squared term or is it a cubed term? Is it a cube? 2 is a squared term, isn't it? 4 is. It's a 2. And x squared is a squared term. So that first term is a 2x upon squared, isn't it? It's a squared term. Now is 49 a squared term? Yeah, it's a 7. So if this is A and this is B, 2x is A and 7 is B, then in that algorithm it says we have an A squared minus B squared scenario. How does that factor? How does A squared minus B squared factor? The algorithm says what? 5A says it factors A plus B, A minus B, right? So we've got to bring this term down. So the A is really what? 2x, and the B is 7. So this A is actually 2x, right? The B is 7, and then it's A 2x minus the 7. And then we have this completely factored. Look at 108. It says x to the 6th, y to the 6th, minus x cubed, y cubed. Now that's a polynomial descending order. The leading term is positive. Does it have a common factor? Okay, it has an x cubed y cubed. Now, out of the x6, y6, you take x cubed, y cubed out, what do you have left? Okay, you have an x cubed, y cubed. Now, minus, if you take an x cubed, y cubed out, what do you have left? 1. Does everyone understand why it's 1? You distribute it back through, you've got to get back to that value. Now then, if this term is completely factored, the question is that factored? Well, it's a binomial. So it has 4 different types of binomials. Binomial difference of squares, sum of squares, difference of cubes, sum of cubes. Does it fit into any of those categories? Well, the question is the x cubed y cubed, is it a squared term or a cubed term? It's a cubed term. What's being cubed? xy, right? Now, is the 1 a cubed term? The neat thing about 1 is 1 can be 1 to the first power, 1 can be 1 to the second power, 1 can be 1 to the third power, can be 1 to the fourth power, fifth power, and so on. It'll fit into any power that you want, right? In this case, we want it to be third power. 1/3 is 1. Now then, this is of the type where it's a cubed minus b cubed. What does your algorithm say that factors into? A minus b. Now, that's where your algorithm sheet is going to come in handy to try and remember that. So now, what we want to do is get this thing factored into this form. We want to be sure and bring this thing down, the x cubed y cubed, because it's part of the factorization. So now a, what are we going to write for a? What are we going to write for this a? xy. See, this is a, and this is b. So it's a xy minus 1, and then it's going to be, it would ultimately be that, but you could write it this way, you know. Then you'd write what? xy times 1, right? Plus 1 squared. Now, to clean it up, this would be x cubed, y cubed, xy minus 1, and then it would be like Skylar said, this would be x squared, y squared, then you wouldn't put the 1 in there, you just put xy, and then you just put 1. And this is what an answer book will probably be. Okay. 110. 6x to the 5th plus 74 x4 plus 24 x3. So it's a polynomial descending order, leading terms positive. Is there a common factor? Okay, does 6 come out of 74? No. So then you have a choice of either 2 or 3. Well, a 2 is going to come out, isn't it? Every one of those are even numbers.
Yeah.
So if you say, well, I'm not sure whether, 6 don't come out, the 2 comes out, that, if the 6 don't and the 2 comes out, the 3 can't, right? So the 2 comes out. How about a variable? What comes out? X cubed. Every one of those has an x cubed. So 2 out of the 6 is 3, and then x cubed out of x5 is x squared. Take the 2 out of 74 is 37. X cubed out of x4 is just an x, right? 2 out of 24 is 12. And x cubed out of x cubed is just now you can see the numerical coefficients of 3, 37, and 12 have nothing in common, so, and we've got the common factor right. Now, this thing is completely factored. This one, we've got to go on some more. It's a trinomial, descending order, leading term positive, so it cancels out all those binomials. Number 5 in your algorithm. It's a 6 trinomial. Is it a special case? Well, you can rule it out right away. The 3 is not a squared term. It can't be a special case trinomial. So if it factors, it's going to factor trial and error over the integer into a couple of binomial pairs. Now, remember I'm saying if it factors. Don't know for sure because it might not. Now, what do we put in the first term of those binomials? An x, don't we? Because we have to have an x squared in the first term of that polynomial. Now, we're looking at sign. We look at the constant term and it's positive, so we say it's the same sign. What sign depends upon this one? Both are what? Positives. Now, when both are the same sign, what you want to be thinking about is this 37, is it a sum or a difference? It's a sum. If those were opposite signs, then you'd think, I'm looking for a difference when I'm looking at my factorization. So the integer factors of 3 are 1 and 3. And now as you go along, you keep thinking, is there a way I can get a sum of 37? 1 and 3, 1 and 12. Can I get a 37? How about 3 times 12? And 1 times 1?
Yeah.
That's the way it works, isn't it? So, now, notice I made a little error when I did this. This was supposed to be a plus, because both have to be the same. So, I have to put the 1 and the 12 in. Makes no difference where I put it. But now it makes a difference. That 3 has got to be associated with, what did we do to get to 37? 3 times 12 and 1 times 1, okay? The 3 has got to be associated with the 12. Because 3 times 12 is 36. 1 times 1 is 1, and 36 plus 1 is 37. That's how we figured out that. Right, Skylar? Okay. So with the 12 has got to be associated with the 3. That means the 3 goes right up here in the front, don't it? So now we've got it completely factored. Do not forget to bring this term down, or else it's wrong. Okay, 120 says x cubed minus 2x squared minus x plus 2. Okay, the algorithm says descending order leading to a positive common factor. Is there a common factor? No, isn't there? No common factor. Now, it's not a binomial. It's not a trinomial. So, not a binomial means we can skip 5. Not a trinomial, we can skip 6. 7 says a polynomial with 4 terms. Is that what it is? It's a 4-term polynomial. What's the algorithm say to try? Group it. So that means group descending order with the leading term positive. Group the first 2, put a plus, and then put the last 2 with their signs in it. Now in the first grouping, what are we going to do? Common factor, is there one? Okay, if x squared comes out, and we have what? X minus 2. Now we want to have that binomial with a leading numerical coefficient of positive. What are we going to have to take out of that second group? A negative. So we put a minus out front, x minus 2. Now we look at this, and we look at that. Do we have a common factor? What is it? X minus 2 comes out. And then we have, for the first one, we have what left? An x squared. And for the second one, we have a minus, what do we have left? A 1, right? When we distribute this back across these two, we get this, right? Now then, we look at this, we say, can that be factored any further? No. This one can be. Because that's a binomial what? There's 4 choices of binomial. Difference of squares, sum of squares, difference of cubes. It's a difference of squares, isn't it? What's being squared in the first case? What's being squared in the second? 1. That 1's a real tricky one because it can be cubed and doing all that stuff too. You've got to kind of remember that. And the difference of squares, if you look at your algorithm, says it factors into a plus b, a minus b. Where a is going to be what? The x, and the b is going to be the 1. So now we bring this factor down. Don't forget to do that. X minus 2. And then factor the x squared minus 1 into x plus 1, right? X minus 1. Now you look at each one of those binomials and you say, well, they're not. Sums of squares, differences of squares, sums of cubes, differences of cubes are done. That's completely factored. Okay? $124. A to the 2n plus 2 minus 6 a to the n plus 2 plus 9a squared. Is there a common factor? If you remember, in that square box at the bottom, you can write that first term as a to the 2n times a squared, can you not? Then you can write that second term as 6 a to the n times a squared, right? Plus 9a squared. Now, is there a common factor? A squared is common, isn't it? A squared. This is a to the 2n minus 6 a to the n plus 9. So this a squared is completely factored. The question is that trinomial completely factored? Can you write that trinomial as a second degree trinomial? If you recall, what you do is you look at this term right there. And if this can be written as a second degree trinomial, then that first term has got to be a to the n, the quantity squared. Is this term and that term alike? Yeah. Always will depend upon this thing and whether you can write that first term as this one squared. So then what it looks like. And now that's a second degree trinomial in terms of what? A to the n. Now then, the next question is this thing right here, is that a complete square? Is that a special case? Excuse me. Well, if it's a special case, the first term would have to be a square term, and it is, right? an squared. Is the last term a square term? 3. Is this a positive number? Yes. Now, to meet the criteria for that to be a complete square, this middle term right here has got to be 2 times this term times that term. And it is. That's a special case trinomial. And because this is a negative right here, its special case is a to the n minus 3, the quantity squared. And don't forget to bring that down. So this is completely fact. If you don't see that it's a special case trinomial, you can factor trial and error over the integers and you have the same thing. It's just, once you get this down, you can see it pretty fast. Now, to get the idea of complete squares, I want to look at 128. X squared plus kx plus 36. And the question is, what would k have to be to make this a perfect square? Well, what you always do is the first term a square term? Is the first term a square? It's an x squared. Is the trailing term a square term? 36? 6. Now, the middle term to be a complete square would have to be 2 times the first term times that trailing term. So k would have to be what number? 12? See, if this were x squared plus 12x plus 36, it would be written as x plus 6 the quantity squared. Okay, so let's look at B. Four x squared minus kx plus 25. Is the first term a square term? What is squared? 2x, right? Trailing term is squared term. What is it? 5. So to be a complete squared, it has to be 2 times the first term times the trailing term. What would k have to be for that to be a complete square? It has to be 2 times 2 times 5. 20. So what this would have to be is 4x squared minus 20x plus 25. You see how it's just showing you what has to happen. Let's look at C, which is 49 x squared plus k xy plus 64 y squared. So if it's a complete square, is the first term a square term? What is it? 7x, isn't it? Is the trailing, this is a plus. Is the trailing term a square term? What is it? 8y. So what does k have to be? Well, it's got to be 2 times the first term times the trailing term. So k would have to be what? 2 times 7, 14 times 8, 112. So if this were 49x squared plus 112xy plus 64y squared, then it would be 7x plus 8y quantity squared. And that's the way you want to start looking at things when you're starting to factor, because it's so much quicker and faster than trial and error. All right. Now we're ready to look at 7.5. 7.5 is just everything that we've studied in 7 put together. If I gave you a quiz or a test for chapter 7, and I took the problems out of 7.5, I would cover everything that we've done. It's just putting it all together. Now what it is, it's getting real close to, at this point, of word problems. How do you solve word problems? And what we're adding is we're adding an equal sign. And the principle, which is the last statement in your algorithm, says that if you have factored your problem into 2 factors, and you have 0 by itself on one side, the only way that you can get that product to be 0 is that either A has to equal 0, or B has to equal 0, or both A and B has to equal 0. So you notice in the algorithm, what does it say? It says, number 1, expand your product. Number 2, do what? Get 0 by itself on one side. This has got to be done. You got to get it by itself. And you got to get it right off the bat. Then what you're going to do is descending order, leading term positive. Then you're going to take a common factor, and you're going to go through the factoring of this side of your problem. And once you get it completely factored, then you drop down to the bottom, number 9, and that uses this principle to solve here for your solutions to your problem. We're going to do problems like this, and then we're going to do word problems. And the word problem is actually, if you can do the word problem, then you have actually taken the math and put it to practical use. If you cannot use solve word problems, math has done you no good. It only does you good if you can, because what are you going to see out in the real world? Just a whole bunch of words, right? Here's a piece of ground that is 6 feet wider than it is long, and you know, we want to have the thing be 75 square feet in area. What's going to have to be the length of it? And you're going to have to figure out what the equation is, factor the problem, solve the thing for the solutions, and get what the length and width is. So those are the kinds of problems that you run into. Now, the first set of problems, 2 through 15, they have set it up so that most of the work is done for you. Notice they have done any expansion necessary. They've gotten 0 by itself on one side of the equation. They have got it completely factored. And all you have to do is do what? Apply the principle. You just got to take the first factor, set it equal to 0, and the second factor and set it equal to 0, and see what makes that true. That says y equals a minus 3, or y equals a minus 2. Now in that case, if you put either one of those two into that original problem, into here, if you put minus 3 in there, this would be minus 3 plus 3, put y, and then put minus 3 for y plus 2. Notice this one is 0, this number is a minus 1, and 0 times minus 1 is 0, so it makes it a true statement. If, on the other hand, you put this in, you would have minus 2 plus 3, then you'd have minus 2 plus 2 equals 0. This first one would be plus 1, this would be 0 equals 0, and it would make it a true statement. So there's only two numbers that y can be to make it a true statement. That's all you're solving. Yeah, I'll do another one from that group, mainly just because people tend to forget to solve for this one. Now this one, everything's been done for you. 0 by itself, it's been factored, everything is done. So all you have to do is apply the principle. That says that x equals 0. This is the one that people forget. I don't know why, but they will not do that. When it's factored into x times something, that's saying that x equals 0 or x minus 5 equals 0. So this is one of your solutions. The other one is x is equal to 5. The only reason why I did it is because for some reason this part of that solution people forget to do. And I'm not sure why. That's my observation after years of teaching. 18. So we'll skip down to 18. Now this one is not completely factored. Now if you notice the algorithm says expand, the expansion's done for you. It says get 0 by itself, the 0 by itself is done for you. Then common factor, this particular problem has no common factors, right? But it is not completely factored. So it's a binomial. Now, binomial, you have four options. Difference of squares, sum of squares, difference of cubes, sum of cubes. Does this fall into any one of those categories? Difference of squares. What's being squared in the first place? 49. Okay. Sorry. So what's being squared in 4x squared? 2x. What's being squared in 49? 7. So difference of squares with factors into a plus b, a minus b. So then the factorization is going to be what? 2x is a plus 7 times 2x minus 7. And this is equal to 0. Don't forget to bring this down. And that is that equal sign. Now then we apply the principle. 2x plus 7 equals 0, or 2x minus 7 equals 0. So this one says 2x equals minus 7, x equals a minus 7 over 2. There's one of your answers. This is 2x equals 7, x equals 7. There's the two answers. If you want to check it, check these two answers back up into your original problem. And what you would do then is you'd say 4 times a minus 7 over 2, the quantity squared, minus 49 equals 0. This would say 4, and when you square a minus 7 over 42, what do you get? 49 over 4 minus 49 equals 0. 49 minus 49 is 0 on this side, 0 on this side, makes it a true statement. Be sure if you're checking it, don't go back up here and check it. Don't go back up here and check it. Go clear back up there and check your question. Because you might have made a mistake coming down. 22. Saying x squared plus 6x x plus 8 equals 0. So there's all expansions done. The 0 by itself. Is there a common factor? No common factors. It's not a binomial, it's a trinomial, so you run 6. Is it a special case? Well, that's not a square case. 8 is not square. So it's not a special case. So if this factors, it's going to factor by trial and error into a pair of binomials. Don't forget to put equals 0. Now what is that first term going to be in those binomials? X and X. The sign, this one says same sign, what sign?
Positive.
Both positive. Now, both the same sign means this middle term is a sum of the integer factors of 8. What two numbers times itself is 8, whose sum is 6. 4 and 2. So you put 4 here, 2 here, completely factored. You drop down to the bottom of your algorithm. It says apply the principle. So you go x plus 4 equals 0, or x plus 2 equals 0. That says x equals minus 4, or x equals minus 2. Now when you put either one of these two solutions back into this original problem, it should make it a true statement. Okay. 26. 2a squared minus 9a minus 5 equals 0. So it's descending order, leading term positive, they've already expanded, that's 0 by itself. No common factor. Trinomial, not a special case. So it's going to be trial and error, right? Put your equal 0 there. What's going to be your first term? A and A. What's the signs? Opposite, plus and minus. Now that 9 is going to be a sum or difference. There'll be a difference because they're opposite signs. So now you take your integer factors of 2, integer factors of 5, and is there a combination such that the difference is 9? So what do you have to do? The 2 with the 5 and the 1 with the 1, and the difference is 9. 2 times 5 is 10. So now, which one of these two goes where in the plus or minus position? 5 is negative because the larger product has got to be negative. And the 2 times 5 is 10 is the larger product. So the 5 goes there. That means the 1 goes here out of those two. And the 2 is associated with the 5, so it's out front here, right? Now we take 2A, apply the principle, completely factored. So this says A equals a negative 1/2, and this says A equals 5. And there's my 2 answers. We'll drop down to 34. A squared plus 5A equals a minus 4. Now notice there's no expansion to be done here, but it's 0 by itself. What are you going to have to do to give it in descending order, leading term positive, and 0 by itself? Move the minus 4 over to positive. So you'll have to go A squared plus 5A plus 4 equals 0. Now 0 is by itself. That you have to do before you start factoring. Now you go common factor, none. It's a trinomial, so 5 is out, binomials. Trinomials are in. Is it a special case? Well, this is a squared term, that's A. This is a squared term, that's 2. So the leading and trailing terms are squared. The middle term would have to be 2 times A times 2. This has to be what to be a special case? The 5 would have to be a 4. It's not a 4. So this is a trial and error over the integers. And it's going to be what? An A and an A. And then the sum, both pluses, right? So what numbers? Product is 4, sum is 5. Okay, 1 and 4. So it's A plus 1 equals 0, or A plus 4. And A equals minus 1, or A equals minus 4. And there's your answer. Okay.